Hey. The topic I am going to discuss is coefficient of variation and standard error of mean. Coefficient of variation. The coefficient of variation, CV, is a measure of relative dispersion that provides a standardized way of comparing the variability of different data sets with different units of measurement or means. The CV is calculated as the ratio of the standard deviation to the mean, expressed as a percentage. CV equals standard deviation by mean into 100. The CV provides a unit-free measure of variability and allows for comparison of the dispersion of data sets with different means and units of measurement. A CV of 0% indicates that the data has no dispersion, as all values are equal to the mean. A CV greater than 0% indicates that the data has some dispersion, with a higher CV value indicating a greater degree of variability. Example. Consider two data sets with the following values. Data set 1. 3, 4, 5, 6, 7, and data set 2. 10, 20, 30, 40, 50. Find coefficient of variation and compare the variability of these two data sets. CV equals standard deviation by mean into 100. For data set 1. 3, 4, 5, 6, 7. Mean, mu, equals 3 plus 4 plus 5 plus 6 plus 7, by 5 equals 25 by 5 equals 5. Variance, sigma square, equals summation of xi minus mu square by n. In my previous video, I have explained about calculating variance and standard deviation. I recommend you to watch that video, link is provided in the description. Variance, sigma square, equals summation of xi minus mu square by n equals 3 minus 5 square plus 4 minus 5 square plus 5 minus 5 square plus 6 minus 5 square plus 7 minus 5 square by 5 equals 4 plus 1 plus 0 plus 1 plus 4 by 5 equals 10 by 5. So the variance is 2. Standard deviation, sigma, equals square root of variance, equals square root of 2 equals 1.4142. So, mean equals 5, and standard deviation equals 1.4142. CV equals standard deviation by mean into 100 equals 1.4142 by 5 into 100. CV equals 28.28. Coefficient of variation, CV, for data set 1 is 28.28%. For data set 2, 10, 20, 30, 40, 50. Mean equals 10 plus 20 plus 30 plus 40 plus 50, by 5 equals 150 by 5 equals 30. Variance, sigma square, equals 10 minus 30 square plus 20 minus 30 square plus 30 minus 30 square plus 40 minus 30 square plus 50 minus 30 square by 5 equals 400 plus 100 plus 0 plus 100 plus 400 by 5. Variance, sigma square, equals 1000 by 5 equals 200. Standard deviation, sigma, equals square root of variance, equals square root of 200 equals 14.142. So, mean equals 30, and standard deviation equals 14.142. CV equals standard deviation by mean into 100 equals 14.142 by 30 into 100. CV equals 47.14. Coefficient of variation, CV, for data set 2 is 47.14%. CV of data set 1 equals 28.28%, and CV of data set 2 equals 47.14%. In this example, the CV of data set 2 is larger than that of data set 1, indicating a greater degree of variability in the values of data set 2 compared to data set 1. The CV can be useful in comparing the variability of different data sets, especially when the data sets have different means or units of measurement. Variation of mean. The mean is a measure of central tendency that represents the average value of a data set. Variation of the mean refers to the change in the value of the mean over time or in different samples from the same population. For example, if you collect data from a random sample of individuals each year and calculate the mean of each sample, you would expect some variation in the mean from year to year, even if the population mean stays the same. This variation in the mean is a result of random fluctuations in the sample due to sampling error. In statistical analysis, it is important to understand the variation of the mean in order to make inferences about the population from the sample data. The variation of the mean can be characterized using concepts such as the standard error of the mean, which provides a measure of the standard deviation of the mean of multiple samples from the same population. Standard error of mean. The standard error of the mean, SEM, is a measure of the variability of the mean of multiple samples drawn from the same population. The SEM is calculated as the standard deviation of the mean of the samples, and provides a measure of the precision of the estimate of the population mean. SEM equals standard deviation by square root of sample size. The SEM decreases as the sample size increases, indicating that larger sample sizes lead to more precise estimates of the population mean. The SEM provides a measure of the variability of the mean across different samples, and can be used to calculate confidence intervals around a mean. Example. Consider a population with a mean of 100 and a standard deviation of 10. If you draw a sample of size 9, the standard deviation of the mean of the sample would be SEM equals standard deviation by square root of sample size equals 10 by square root of 9 equals 10 by 3. SEM equals 3.33. This means that the mean of the sample is likely to fall within 3.33 units of the population mean. Note: to calculate a confidence interval for the population mean, the sample mean can be plus or minus the SEM multiplied by a critical value from a standard normal distribution. In Unit 3 we will learn the estimation of confidence intervals. Their SEM will be used. So don't forget to subscribe. Thank you for watching. If you found this video helpful, please give us a like. Subscribe for more videos and also share with all your pharma mates. Thank you.